Hi, and welcome to our lesson on central angles. So let's start off with a few definitions. A central angle is an angle in a circle whose vertex is at the center of the angle, hence central. Central angles and their intercepted arcs have the same degree measure. Minor arcs are less than 180 degrees and are named using 2 points. Major arcs are more than 180 degrees and are named using 3 points. And then a semicircle is half a circle and has a measure of exactly 180 degrees. Semicircles are also named using 3 points. So if we look at our picture over here, angle ACB, right here, that would be a central angle because it has the vertex in the center of the circle. And then an intercepted arc is the part of the circle that is inside of the angle. So ACB, we have this arc AB inside of it, and as long as it's less than 180, that's what's called a minor arc. If it's more than 180 degrees, or in other words, if it is more than half the circle, it's a major arc, and you would need 3 points. So A, D, B to go all the way around. If you're exactly half, that's just a semicircle. So let's find some measures of angles here. When you're dealing with central angles, it's just like if you're dealing with regular angles. We've just put a circle around the outside, but it's the same premise. So arc RS, the central angle and its arc have the same measure in degrees. So if the central angle is 110, its intercepted arc is also 110. Arc RTS, that's a major arc, so RTS. To find that, we're going to use subtraction because RTS, the green one, plus RS, which is the red one, which is 110, gives me a full circle, which is 360. So subtract 110 from each side. RTS, that arc, equals 250 degrees. And then RST. RST is different than the one we just did because it goes R, around to S, and then to T. RST has a measure of 180 degrees. That's because RT is a diameter, and so a diameter creates a semicircle that's exactly in half. So if we want to name a major arc, remember that a major arc has to go more than half the circle. So an example would be RTS, because that has a measure of 250. RTS. That would be a major arc. We could also say SRT, because SRT also goes more than halfway around. Now, these are the same forwards and backwards. So STR is the same thing as RTS, and TRS is the same as SRT. A minor arc is anything less than half. So RS would be a minor arc because it's less than the diameter. It's less than 180. It's 110. ST is also a minor arc because it would have a measure of 70 degrees because that makes a straight line, which is a linear pair. So let's look at some of this solving. Here we want to solve for x. So what we're going to do is I noticed that I have an angle measure of 45 and 75 in the center at the angles. So I'm going to take this expression and move it to the inside so that they're all in the same location. central angles and their arcs have the same measure, so I'm allowed to do that. At this point here, this is just like calculating for angles. So finding angle measures and solving. These angles are vertical angles. Vertical angles are congruent, so 8x plus 11 equals 75, because these are vertical angles. We'll put that down as a note to ourselves. Subtract 11, negative 8x equals 64, divide by negative 8. So x equals negative 8, because 64 divided by negative 8 is negative 8. And we'd be done with that problem. Solve for x again. Now I notice that I have angle measures on the outside. You could take your expression and move it to the outside, or you can move your angles inside. It does not matter which way you do this. I am actually going to move them inside because that's just a preference of mine. It keeps everything a little bit more condensed and in the same location. Alright, so now when I look at this, I'm looking at these as just angles, and I'm ignoring the circle on the outside. Something that I notice is, right here, I have a diameter, and those three angles make up that straight line. So what I can do is use angle addition and add these three separate angles together and set those equal to 180. 65 plus 11x plus 3 plus 46 equals 180 degrees. The three of them combined gives me a straight line, which is 180. So now I'm going to go ahead and combine my like terms. So 65 plus 3 plus 46 is 114. 11x plus 114 equals 180. I'll subtract that from 180. So 114. 11x equals 66. Divide by 11. X equals 6. Here's a thought process. If I have this circle here, it has a radius of 7 and an angle measure of 145. Which of these arcs is congruent to AB? Remember that congruent means it's the exact same size and same shape. So I need to check all my measurements. This first one has a radius of 11 and an angle measure of 145. These radii aren't the same. This circle's actually bigger, which means the arc is also bigger. So this will not work. Our second one has a radius of 7 and an angle of 145. Because this has the same radius and the same angle, that's going to give us a congruent arc. It's going to have the same size and the same shape. So size, think of that as your radius, the size of the circle, and the shape, how much of the circle. Okay, is it a little bitty arc, or does the arc go really far around? The same shape. So there's different things about circles that are congruent. We can't look for angles, we can't look for side lengths. But congruent circles are congruent when they have a congruent radius. That's the only measurement that we have for a circle is a radius. Everything else relates to that. So if the radius is the same on two or more circles, then those circles are congruent. And then congruent arcs. Two arcs are congruent when they have the same angle measure and they're part of the same circle, or when they have the same angle measure and congruent radii. So again, it comes to that size and shape. Same radius, same angle measure. And that's all we have for central angles. So make sure you remember, central angle equals the arc measure. And everything that we've learned about angles, everything you know still applies. vertical angles, congruent angles, linear pairs, all of those things still apply. And then we had some vocab. Minor arcs are less than 180. A semicircle equals 180. And then a major arc is more than 180. And that's it for central angles.